Hello, everyone, and welcome to another episode of All You Need to Know with your host, Sarnya Gopinath. A lot of things are happening in the world right now, AI and otherwise. I hope that everyone watching this is safe and well. At the time of this recording, just like another instance not too long ago, we've become acutely aware of the impact of global supply chain and geopolitics on the world that affects us, right from our availability of vegetables to even the development of AI. On this podcast, we often discuss the fancy new thing, the new feature by the new AI company, the new products that have been released, and so on, as well as valuations. But now is as good a time as any to discuss their dependencies and how that will affect the growth of global AI. Today, we're going to be discussing the global compute race, the other supply chain issue that we all need to be aware of. The race to own, control, and stockpile global AI compute, and why this race has more in common with the nuclear arms of the 1950s rather than any other product tech supply chain you've ever heard of. Okay, let's take a step back. What exactly is compute and why does it matter? Compute is the ability to do mathematical calculations at enormous speed and scale. Training an AI model is effectively millions of number multiplications happening simultaneously over and over. The creation of our AI systems are dependent on compute, and compute is a very physical, tangible activity. A building, a rack of chips. Every query you type into either ChatGPT or Claude or Gemini depends on giant server farms and electricity and physical machines and water. Why is this understanding important? Let's look at the internet. We interact with it as this global, borderless, democratic thing. And in many ways, it is. It is this giant fiber. But the running of the internet, the plumbing, the undersea cables, the cloud servers, the domain registers are largely owned by a handful of American companies. Now, the exact same thing is happening in the AI world, except much faster and on a much larger scale. On a recent earnings call, Jensen Huang of NVIDIA estimated that about $3 to $4 trillion will be spent on AI infrastructure by the end of this decade. That's $3 to $4 trillion. Let's process this. India's GDP as of 2024 was $3.7 trillion. We are talking about a single industry rivaling the GDP of the fifth largest country in the world. That is absolutely non-trivial. And we need to understand how the infrastructure, the ownership, and the supply chains of this entire industry works and how the story is going to play out. Ever since this generative AI boom started in around, let's say, 2019, 2020, in its new avatar, we've all been hearing that the center of it has been NVIDIA. NVIDIA is a chips and GPU manufacturing company founded by Jensen Huang, Chris Malachowski, and Curtis Priem in 1993. As of today, it also owns about 80% of the market share in AI chips, GPU manufacturing, and the CUDA software stack, which essentially forms the training and running of our favorite large language models. Let me give you this analogy. Imagine that you are in the house building business, right? And you have figured out that there is this house that everybody wants to buy. Everybody wants a version of it, and you're one of the few people in the world who are building this house. But it turns out that to lay the bricks of this house, the bricks are manufactured by exactly one company. And that specific kind of brick costs about $30,000 to $40,000 per piece and is sold out for the next 12 months. That is exactly what the NVIDIA chip unit world looks like today. As of date, NVIDIA's Blackwell GPUs are sold out for the next 12 months, meaning orders are only on a fulfillment basis till about 2027. This is not just a temporary blip, but is soon going to be expected as the new normal. Let's take a step back. What does the manufacturing of an NVIDIA chip actually entail? What are its global dependencies? What are its vendors? And we need to understand all of this before we can just be like, hey, why isn't NVIDIA just manufacturing more chips? There are limitations. This image is just a high-level depiction of the global players involved in NVIDIA's supply chain. Have a look at the different nations they come from. And in some companies, the companies themselves are also giants and have very niche areas of operation. Let's look at the manufacturing piece, for example. TSMC is a Taiwan semiconductor manufacturing company. It is the primary manufacturer of NVIDIA chips. ASML, it's a Dutch company that almost uniquely supplies critical lithography machines required by TSMC to print advanced circuit patterns. And that occurs through the chain. Each of those segments and the players involved on it are uniquely positioned to be playing that role and also have downstream dependencies for each of their products. This is something we need to understand when we look at the bottleneck for the AI race as we know it. The fight for chip availability is one of the major bottlenecks for all AI systems. Think about that. All these nations and all these companies coming together is critical to OpenAI achieving its milestones, Anthropic's IPO, even the realization of AGI that we all are bracing ourselves for. Okay. Now, this sounds obviously like some major dependencies. The question is, why aren't we all de-risking from NVIDIA, and why aren't other companies creating more chips? Great question. The NVIDIA dominance is actually on two fronts, both hardware and software. CUDA is NVIDIA's proprietary software ecosystem, and it's a language that AI researchers write in. So hypothetically, even if tomorrow someone released a chip that was better than NVIDIA's hardware, you would still have the problem that every AI engineer has been writing in CUDA for 2 decades and doesn't want to relearn. That is a serious moat. But on the hardware side, this moat could be cracking a little bit. Analysts predict that NVIDIA will remain dominant in the training market to the tune of around 90%, but in the inference market, this could fall back to 20 to 30%. What is the inference market? So when you're asking your LLM or your AI a question, the processing and retrieval of information and the answering of that question, that is the inference piece. As of 14th March, Meta is considering using Google-designed AI chips, that is the TensorFlow processing units, the TPUs. And NVIDIA is for the first time acknowledging this advancement. This has been a while in the making, and for the longest time, NVIDIA has been saying, hey, we're fine, we're not going to get affected by this. But for the first time, with Meta actually taking a bet and possibly renting and eventually incorporating Google's TPUs, NVIDIA is saying, hey, good job, Google. And then also saying, we still rock. But even acknowledging Google as a player in the game is substantial to the story so far, where NVIDIA has been considering itself and the GPUs as all that you need for AI training and inference. This is a major inflection point, wherein the industry is deviating and saying, hey, we're going to have different chips for the inference layer. This has also resulted very recently in reports of NVIDIA also considering varied chips for the inference layer. This is a market stage change in the GPU story so far, and also the way that we see NVIDIA's dominance play out. This is also important to note because Google is not the only challenger in this space. With the perspective that the inference layer is really the commercial game changer, we have players right from China as well as several other startups throwing their hat in. This is the theory so far. Let me translate this into numbers. In January 2025, Project Stargate was announced. Current status of Project Stargate is a little dubious, but at that point, it was announced as a joint venture that was going to invest up to $500 billion in AI over 4 years. As of now, Amazon is projecting $200 billion in cap expenditure in 2026 alone. Google is projecting $185 billion, and Meta is estimating up to $135 billion. Put together, all hyperscalers are planning to spend about $700 billion in data center projects in 2026 alone. 700 billion. That was the summary of what is compute, why it matters, what are its dependencies, and literally the numbers involved in processing all of this. The TLDR is everybody's out to win the AI race, and critical to that is winning the global compute race, the need to invest more and more eye-popping money. When before everybody just starts pumping in money and, buying new stocks, let me point out a couple of small pebbles on this path that these companies could crack their skulls on. The first, the multi-stakeholder dependency that we just witnessed. That is across companies, countries, and a million other vendors downstream of this, right? Okay, maybe not a million, or at least a couple of hundred, which all have to work together in tandem for the timeline and the capacity that we are expecting. The nations and vendors required to make this vision come true are numerous and utterly diverse. Second, the power grid. This entire story of billions worth of data centers requires a truckload of electricity and energy. And energy, as we all know, is not an infinite resource. The trade-offs of this energy will be imminent and is going to come to our doorstep pretty soon. For context, global data center electricity consumption was estimated at 460 terawatt hours in 2022. That is now projected to rise to more than 1,000 terawatt hours. That is roughly the electricity consumption of Japan for data centers alone. Of Japan. The third is a similar dependency on water. By 2028, data centers across the US alone could collectively use as much water as 1.85 million households across the country. There are several other dependencies, of course, for the growth of AI, such as data and other infrastructure, but that's for another episode. With all of this, let's come home. What is the India positioning story? In earlier episodes, we have covered in detail India's fantastic India AI mission, which covers multiple prongs of what is required for India to be a global AI powerhouse, whether it is the supporting of sovereign models such as Sarvam AI or the Pashni project, or even the creation of the nationwide compute data infrastructure as a shared public infrastructure resource, with the objective of targeting 10,000 and eventually 100,000 GPUs. Most recently, the India AI Summit saw substantial investment pledges. Reliance pledging over $110 billion and Adani Group pledging $100 billion investment in AI infrastructure by 2035. Another substantial factor is India signing the PAC Silica Coalition, which effectively is a semiconductor framework which now includes India as a trusted node in an effort to create global semiconductor supply chains away from China. In all of this, it is completely non-trivial, all of these efforts towards putting India on the global AI stage. Each of these efforts form part of a cohesive vision of it for India to become a global AI powerhouse. And that's the way the India AI mission is architected. But this is a very good start, and we have a very long way to go. Challenges of power generation and GPU ownership will come to our doorstep as well, and we need to have a strategy as to how we're going to deal with it. Global supply chains, as we just saw, are already overwhelmed. They have customers across the world, across companies, across countries, and we may not be able to get more GPUs even if we want to. For context, estimates for running frontier models require clusters of about 50,000 to 100,000 GPUs running for months. As of December 2025, India had onboarded 38,000 GPUs that were being offered at a subsidized rate as part of the shared compute infrastructure project. All of this is important and critical to us realizing our increased power and position in a global AI race. Okay, that was a lot of information. Where do we go from here? Now, I appreciate all the predictions of AGI and revenue numbers and valuations as much as the next person. But I want us to understand that there are real physical limitations to reaching this hallowed land. And it is equally important to understand the geopolitics of it all. During COVID, in a time not so far away or long ago, we saw how a chip shortage threatened a lot of the tools that we had access to. We saw chip shortages impact access to computers, access to cars, even microwaves in certain senses. And while that was a crisis of a different nature, it's important for us to understand how interconnected this entire system is. And we have a very few number of countries rushing to claim the throne, but the dependencies of all of these countries are larger than we all talk about. India's position and its choices are absolutely critical at a time like this. The question remains of how India will play out as a sovereign player and the contours of its dependency in the various components of AI, whether it is data, compute, or the access to chips. All of this will be critical in the way and the choices that we make in roughly the next 3 to 4 years. That is the timeline. And that is the window that we're working with, which is why this story deserves all of your attention. It'd be fantastic to know what you think about this and what are your thoughts about the global AI compute race, how it's playing out, how many predictions have gone wrong, and maybe your own predictions for how it's going to work out. It was great speaking to you as usual. Everybody, please stay safe. And until next time, see you. Saranya Gopinath signing off.